In this video, we're going to look at some single displacement reactions. So let's start with the definition here. Essentially what we're doing is we've got an element that's going to be reacting with an ionic compound, and we're going to have a couple of atoms switching around. Now there are a couple of cases, so let's investigate these cases. So case one is we're going to have our metals or cation switching. So what I mean by this is we've got A as a single atom and we've got BC as our ionic compound, and we're pretending that A is acting as a metal here. So when we look at our ionic compound, we've got B acting as that metal. So these two letters should be switching place. So you're going to get B all by itself and you're going to get AC forming. These are the solubility rules we'll be using in this video. And one other thing you need to mention here is the state of elements. We're going to have a couple of states. So either when single elements are by themselves, they're going to be appearing as a solid, like any metal or some of the nonmetals, or they're going to be appearing as the diatomic gases. Now, there is an exception here, of course, and that's that we've got group A gases that are gases and they're single atoms, but the fact is they're very unreactive, so they're not going to be appearing in this video. So let's go ahead and take a look at one of our case one examples here. So we've got calcium plus silver chloride. So the first thing we have to identify is calcium a metal or a non-metal. Turns out it's a metal. So it will be switching with our metal over here, silver. So those two are going to switch places, meaning, so we've got silver all by itself. And like I said earlier, any element that's by itself is either going to be a metal, or sorry, it's going to be a solid or a diatomic gas, and silver is a metal. So we're going to put it as a solid. Our other compound, we're going to be combining calcium and chlorine together. We're going to get calcium chloride, and we do need to think about its formula. Calcium has a charge of +2, chlorine has a charge of -1. So when you cross these over, you're going to get 1 calcium, and you are going to get 2 chlorines, so CaCl2. And if you look up your halide here in the video, halides are soluble, not one of the exceptions, so we're going to have it aqueous. Now we do have to do a little bit of balancing here. We've got 2 chlorines on the right, so we had better get 2 chlorines on the left. That also gives us 2 silvers, so we'll put a 2 in front of the silver. Let's take a look at another example here. So this time we're going to put sodium with water. Might see this one in class, create some fire, some gases, and the gas is kind of key. Because what we've got going on here is it's not clear to say that we've got 2 metals switching places because we don't have any metals in our H2O. In fact, when you think about water, it's probably easiest to think about it as created as HOH. So what's actually going to switch here in HOH is going to be the sodium and this H. So you're going to put the H all by itself. Now again, you refer back to the diatomic gases. Is H on there? Of course it is. It's the first one, so we're actually going to make it H2. So on the diatomic gas list, we'll put it as a gas. The other thing we've got reacting now, or combining, is we've got the sodium with the hydroxide. And we're going to make sodium hydroxide. And all hydroxides are insoluble, but we have a group 1 exception, so that should make it aqueous. Now this one's a little difficult to balance, and what makes it difficult is we have hydrogen appearing in both of our molecules on the right. And if you count them up, we've got 2, and we've got a third one here. And my suggestion is you always like to even out atoms. So we're going to put a 2 in front here, because that should give us 4 hydrogens on our right side. So that 2 also gives us 2 sodiums. So back to the left, we'll put a 2 in front. And as we move to our last part here, we've got only 2 hydrogens on the left. Putting a 2 in front should give us 4. And if you count up the oxygens, we've got 2 oxygens, and we have 2 oxygens. So that one ends up being balanced. Okay, so let's take a look at our second case here. Now we're dealing with nonmetals or anions. So what that means is that A is going to act, or B, a nonmetal. And when we look at our compound, if this is ionic, well, C is going to be the anion here, or the nonmetal. So meaning that A and C are going to switch places. So you're going to end up with C all by itself and Ba. Now we do have to be careful with these reactions. Firstly, you got to be able to spot that A is in fact a nonmetal and it's going to switch with C. Often kids just switch A and B, which isn't necessarily correct. We also have to be wary of C over here because often it can be a diatomic gas, meaning we'll have to put a little 2 involved in its formula. So let's take a look at an example here. So we're going to put solid sulfur together with sodium chloride. So firstly, we have to recognize sulfur as a nonmetal and chlorine as the nonmetal. So those two are going to switch places, so we get Cl. We think back to our diatomic gas list. Cl is on it. We'll make it Cl2. And it's a gas because it's on the diatomic gas list. So our other compound is going to involve sodium, that's +1, combining with sulfur, that's -2, meaning we're going to get, when we cross it over, we'll get 2 sodiums and 1 sulfur, Na2S. And look that up on our solubility rules here, and that'll be an aqueous. This one's easy to balance. You can start anywhere you want because we have a couple of chlorines here. We also have a couple of sodiums. And so by putting a 2 in front, that should balance both the sodiums and the chlorines.